Hey everyone, and welcome to another deep dive. Today, we're going to be tackling something pretty amazing.
Yeah.
Artificial intelligence that can see, yano,
Yeah,
and understand images just like we do.
absolutely.
But not just any AI. We're talking about large vision language models, VLMs.
Right.
These things are incredible. Imagine asking an AI a question about a photo and getting a detailed response, or having it generate captions that perfectly capture the essence of an image.
It's amazing.
It's mind-blowing stuff. But here's the thing, and this is where it gets really interesting.
Okay.
While these VLMs are great at a lot of things, they sometimes struggle when it comes to specializing in a specific task.
Yeah, that's exactly the challenge that this research paper, From Generalist to Specialist, Adapting Vision Language Models via Task-Specific Visual Instruction Tuning, dives into.
Okay, so let's unpack this.
Sure.
The paper specifically looks at image classification as a key study, right?
Yes, it does. They use image classification, which is essentially teaching AI to identify and categorize images as a way to explore how to make these general-purpose VLMs excel in specialized areas. Think about something like dermatology, where an AI could analyze images of skin conditions and help with diagnosis.
That makes sense. Having AI that can accurately interpret medical images could be revolutionary.
Right.
But you said these VLMs struggle with specializing. What's holding them back?
Well, the paper points to two key hurdles.
Okay.
First, the way VLMs see images, their image representation is often too broad for specialized tasks.
Yeah.
They might understand images in a general sense, but they lack the fine-grained detail needed for something like medical image analysis.
So it's like having a basic understanding of cooking, but then trying to create a gourmet meal.
Exactly.
You need more than just the basics to truly excel.
Exactly. And the second issue is how we're currently training these VLMs.
Okay.
Right now, the focus is on improving their ability to generate text, like predicting the next word in a sentence. But this indirect approach doesn't necessarily translate to better image classification.
So it's like teaching someone to write restaurant reviews to make them a better chef.
That's a great analogy.
They might become great at describing food, but it doesn't mean they can cook it themselves.
Precisely. They're learning to talk about the task, not necessarily perform it with a high level of accuracy.
So how do we bridge this gap? How do we make these VLMs as good as specialists without losing their impressive versatility? That's what this paper is trying to figure out.
Exactly. And this is where it gets really exciting. They introduce a new framework called VITask, which aims to make VLMs as good as specialist models without sacrificing their incredible versatility.
Okay, I'm intrigued. How does VITask work? What's the secret sauce?
Well, VITask utilizes three key strategies. The first is Exemplar Prompting, or EP. Imagine showing the VLM an image, say a medical scan, alongside insights from a specialist model that's already great at interpreting those scans. It's like providing the VLM with expert annotations that highlight crucial visual cues.
So it's like giving the VLM a crash course from a specialist showing them what to look for.
Precisely. But we don't want the VLM to become reliant on these cheat sheets forever. That's where the second strategy comes in: response distribution alignment, or RDA. With RDA, the AI isn't just copying answers, it's learning to think like an expert.
Interesting. So how does it do that?
Well, with RDA, the VLM analyzes the answer patterns of the specialist model, not just the answers themselves. Over time, it starts to internalize those patterns and develops its own intuition. It's like learning from a master chef. You don't just copy their recipes, you pay attention to their techniques, their decision-making process, and you start to develop your own culinary instincts.
That makes a lot of sense. But how do we ensure that the VLM is confident in its judgments? We don't want it second-guessing itself when it matters.
That's where the third strategy, Contrastive Response Tuning, or CRT, comes into play. This is all about building confidence and accuracy.
So how does CRT do that?
Think of it like giving the VLM practice tests. We present it with images and a range of possible classifications, some correct, some incorrect. By comparing its own assessments to the correct answers, the VLM refines its understanding and becomes more adept at distinguishing between right and wrong.
It's like the VLM is going through rigorous training to ensure it can accurately apply what it's learned.
That's a great way to put it. It's like rigorous training that helps the VLM solidify its knowledge and make confident judgments.
So this VITask framework sounds incredibly promising, but does it actually work in practice? Did the research team put it to the test?
They absolutely did, and the results are really impressive. They tested VITask on a wide range of medical image datasets, 12 to be exact, covering everything from X-rays to skin images. They wanted to see how it stacked up against both standard VLMs and those specialist models we've been talking about.
Okay, so they really put it through its paces. And what did they find? Did VITask live up to the hype?
It absolutely did. In
Yeah.
fact, it exceeded expectations. VITask consistently outperformed the competition, proving to be more effective at medical image classification than both standard VLMs and, in many cases, even the specialist models.
Wow, that's incredible. It sounds like VITask could be a real game changer for training AI, especially in fields like healthcare, where accuracy is paramount.
It really does have the potential to revolutionize the field. One of the things that makes these results so compelling is that they tested VITask on such a diverse range of datasets. We're not just talking about tweaking an AI to be a slightly better X-ray reader. They threw everything from dermatology images to complex ophthalmology scans at it,
Yeah.
and the fact that it consistently came out on top is a testament to its adaptability and effectiveness.
It's like they've created an AI system that can learn to be an expert in multiple specialties, which is incredibly valuable, especially when you think about the time and resources it takes to develop highly specialized AI models.
That's a crucial point. Developing those specialized AI models can be incredibly time-consuming and resource-intensive. You need access to massive data sets, powerful computing infrastructure, and a team of experts. But with VTask, you can potentially fast-track that process. Imagine being able to start with a powerful, publicly available VLM and then fine-tuning it for a specific task, using insights from smaller, more readily available specialist models. This could democratize access to cutting-edge AI, making it much easier and more affordable to develop tailored solutions for a wider range of applications.
It opens up a world of possibilities, especially for fields that might not have the same level of resources as, say, a large tech company.
Exactly. And beyond accessibility and affordability, VITask also addresses another real-world challenge in AI, the need for very specific instructions. In their experiments, they found that VITask was remarkably robust, even when given less detailed or complete instructions.
So it's adaptable not only in the tasks it can learn, but also in how it receives and interprets information. That's a significant advantage for real-world applications where we can't always provide AI with perfectly curated data and instructions.
Absolutely. We need AI that can handle some ambiguity, adapt to new situations, and learn from limited information, which is something VITask seems to excel at. There's a great example of this in the research paper. Remember how we talked about the importance of that third strategy, contrastive response tuning, for building confidence and accuracy? Well, they tested this specifically by removing the list of possible diagnoses from the instructions given to the AI for a dermatology dataset.
So instead of telling the AI what to look for, they basically just showed it the image and said, "What do you see?"
Exactly. And as you can imagine, the standard instruction-tuned VLM completely fell apart. It was like it had lost its cheat sheet and had no idea where to even begin. But VITask, on the other hand, handled it like a champ. Its performance dipped slightly, which is understandable given the lack of specific instructions. But it was nothing like the dramatic drop we saw with the standard VLM. This suggests that VITask is learning something deeper, something more fundamental about the task, rather than just relying on explicit instructions as crutches.
That's fascinating. It's like VITask developed a real understanding, not just a memorized set of responses.
That's a great way to put it. And this ability to learn and generalize from less specific information is crucial for developing truly intelligent and adaptable AI.
This research is incredibly promising, but like any good study, it opens up even more questions and avenues for further exploration. For example, the researchers primarily focused on image classification, but AI has the potential to do so much more than just label images.
You are absolutely right. While this research provides a fantastic foundation, there's always more to explore. For starters, the paper acknowledges that its focus on image classification has limitations. While it's a fundamental task in computer vision, many other vision language tasks could benefit from the VITask approach.
What other tasks come to mind?
Think about tasks like image captioning, where AI generates descriptions for images, visual question answering, where it provides answers to questions about what it sees in an image, or even more creative applications like generating images from complex descriptions. Imagine being able to tell an AI to design a new product based on a set of spoken requirements and have it generate a detailed 3D model. These are all complex, multifaceted tasks that require a nuanced understanding of both visual and linguistic information.
It's like they've given us a glimpse of a whole new toolkit for training AI, and now it's up to researchers to experiment with these tools and see what incredible things they can build. It's like we've gone from having a basic hammer and nails to like a whole workshop full of specialized tools, and now it's about exploring what we can create with them. Beyond exploring these other tasks, what other research avenues do you think would be particularly interesting to pursue with this approach?
Yeah, that's a great question. One area that really stands out to me is exploring the integration of VITask earlier in the VLM development process.
Okay.
Currently, they're using it for fine-tuning models
Hmm.
that have already undergone extensive pre-training. However, what if we could weave this concept of learning from specialists right from the beginning?
So instead of giving the VLM like a general education and then sending it to specialized, we'd be incorporating specialized knowledge from the get-go.
Exactly. Imagine if during the initial pre-training phase, we could expose VLMs not just to massive data sets of images and text, but also to curated insights and feedback from specialist models across a range of fields. It'd be like building that specialized knowledge base right into the foundation of the model.
It seems like that could significantly enhance their ability to learn and adapt later on, especially when it comes time for fine-tuning for specific tasks.
Absolutely. And that's something I'm really excited to see researchers delve into.
Yeah.
Another area that I think warrants further investigation is the generalizability of VITask across different domains. While the research focused on medical imaging, which is obviously a data-rich field with very clear applications, how well would this approach translate to other areas?
That's a great point. Medical imaging is one thing, but what about areas like robotics, where AI needs to interact with a dynamic real-world environment? Could a system like VITask learn from the experiences of expert robot operators and translate that knowledge into more effective actions?
Those are precisely the kinds of questions we need to be asking. Could we use this approach to train AI systems that assist surgeons with greater precision by learning from the techniques of the world's best surgeons?
Oh, wow.
Or AI-powered analysts who can predict market trends with remarkable accuracy by tapping into the expertise of seasoned investors? The potential applications are incredibly exciting and far-reaching.
Yeah, it's really mind-blowing to consider all the possibilities. It seems like VITask could represent a significant shift in how we think about AI development, moving away from these siloed task-specific models toward a more adaptable and versatile approach. It's not just about building bigger, more complex AI. It's about making AI smarter and more efficient by tapping into the wealth of knowledge and experience that already exists in the world.
I couldn't agree more.
Yeah.
And for anyone listening who's as captivated by this as we are, I encourage you to check out the full research paper. We'll be sure to include a link in the show notes.
This has been an incredible deep dive into the world of VLMs and the groundbreaking potential of VITask. We've covered a lot of ground today, from the challenges of specializing general-purpose AI to the innovative strategies employed by VITask and the truly awe-inspiring possibilities it unlocks. If this episode has sparked your own AI-powered curiosity, don't keep it to yourself. Share your thoughts, your questions, your wildest AI dreams with us on social media. Until next time, keep exploring, keep questioning, and keep diving deep.